Hello everyone, welcome to Efficient Code and Optimization Techniques for Python Coding Exercise. These are few techniques that you can use to write efficient code as well as optimize it. To start with, you should always use enumerate function. Enumerate takes a collection of tables, that is a list, dictionary, tuple, etc. and adds a counter to it and return it as enumerate object. To start with, you're first going to write a list, say the countries, next we are going to enumerate these countries, that means convert it into enumerate type. Then the default counter that starts with value needs to be initialized. Next, I am going to print list of enumerate countries as well as type of enumerate countries. So as the output, you can see it is added a counter to this. Next, I'm going to again create a list. I'll copy the list. Then using for loop, you can write an enumerate function here. It will give the output as the index and the name of the item. So you can see the countries USA is at 0th index, Canada at 1st, Singapore 2nd, Taiwan 3rd. Next is map function. In Python, map function applies the given function to each item of a given iterable construct, that is list, tuple, etc., and returns a map object. To implement this, we are first going to initialize a tuple, say 100, 200, 300. Then map the result using lambda function. And then convert it into list. Then print the total. So you can see that my total is 200, 400, 600. So this has been applied. First and second element, third, second and third element, they are getting added. So the result gives 200, 400 and 600. Likewise, we can implement Numpy arrays. Numpy arrays are homogeneous and provide a fast and memory efficient alternative to Python list. Numpy array vectorization technique is basically vectorize operations so that they are performed on all elements of an object advanced, which allow the programmer to efficiently perform calculation over the entire arrays. Numpy arrays are very efficient. To implement these, we are first going to import Numpy. Then I'm going to define a function . So here I'm creating a Numpy array, which is an empty array for the length of values. Using for loop, you can calculate the reciprocal . Then I'm going to return the output. After this, I'm going to pass my random integers. So np.random.vanint 1, 15, size, let's say 6, and call the reciprocal function for the values. So you can see the reciprocal output is now available, that is 0.025, 0.5, 0.1, and likewise for the random integer that are getting generated between 1 to 15. Next is using the membership operator. In keyword is the membership operator, which checks whether a particular element belongs to a list or not. It is generally faster to use in keyword to check the membership of an element in the list or any iterable. So to implement this, I'm first going to create my list, say days of the week. And then I want to check if my particular day belongs to the list or not. So for D in days, print first I'm going to print the days. So you can see today is Sunday, today is Monday, today is Tuesday, and then I can check print say Tuesday, in days list. So the output of this print statement has to be either true or false. If this particular element is not present in the list, it will give false, otherwise it's true. So you can see my Tuesday is present in the list days. Likewise, if I check for say Friday, the output is false. Next is use multiple assignment technique. To implement this, I'm going to take 3 variables, say first name, last name, and city, and all these variables are initialized with values in just one statement using multiple assignment. So First name is Steve, last name is Paul, city is New York, so if you print F name, L name and city, it will give the output as Steve, Paul and New York. On the same line, if you want to swap two variables, you can use the use of temporary variable. So how to do that? You can do so using multiple assignment. So A, say let's equals to 5 and B is equal to, let's say, 10. Now if you want to swap, so A comma B is equals to B comma A. Now print A comma B. So you can see the value have been swapped. Next is using comprehension. You can use list comprehension as well as dictionary comprehension. To do so, first I'm going to initialize a list. Let's say list2 is equals to 5, 10, 15, 20, say 20, 50, 50, 60. Then I'm going to initialize a variable, say new list, where I'm going to do the list comprehension. So all the element raised to power 3 for x in list 2. Now print new list. So you can see the output is this. So you can see we have successfully implemented list comprehension. Likewise, we can also implement dictionary comprehension. One, 2, 3, 4, and I'm going to initialize my new dictionary and write my comprehension, say x to the power 2 for x in dict 1 if x mod 2 is equals to 0. Then I'm going to print my new dict. So it will give you the elements being raised to power 2 if the mod is equals to 0. So it's basically for the even numbers. So it forms a dictionary, 2 as the key and 4 is the value. 4 for 4, it's 4 as the key and 16 as the value. Next, you should always use counter. Counter is one of the high performance container data type. To implement counter, you first need to import counter from collections. Then initialize a sample dictionary variable. Then if you want to count, use counter and the name of the dictionary. So it will give you the count of each element for every key that is there in your dictionary. Then comes the iterated tools. We have implemented iterated tools previously as well. In this, we are first going to import iterator tools, then for I in iterator tools dot count, say 30, 4, print I. If I is greater than 30, then break. So this gives the output as 30 and 34. Again, we can also implement another example of iterator tools. Iterator tools are fast, memory efficient functions, that is a collection of constructs for handling iterators. So again, import iterator tools, then initialize a list Once you have initialized your list, then convert into iterator tools using lambda function. So initialize a variable and use group by. Increase, comma, and lambda function. The first element becomes the key. For key, comma, group in your iterator, result is equal to key list of group and then print result. So you can see that my output is west, east, and then this becomes the key, and whatever values that we have initialized in the list becomes the values in the dictionary. Next is using zip. So zip takes one or more iterables and aggregates them into tuple and returns the iterator object. To do so, I'm first going to create a list, say list of students, say Steve, Paul, and Brad. Then I'm going to assign roll number. And next is I'm going to assign marks. So 20, 40, 50. Next, I'm going to zip all three list using zip function. Zip name, comma, roll number, comma, marks. Then convert it into set. Lastly, I'm going to print my zip map. So you can see Brad, the roll number is 3 and the marks you obtain is 50. Likewise for Steve and Paul. Next is use sets. Sets, as you know, remove duplicate elements. So say S1 is equals to 1, 2, 4, 6, 0, 3, and say if you want to add something to the set. So s1 dot add, let's say 10. So, and then next, if you want to update, so you can use update function. I'm going to create few duplicates. So 2, 1, 7, 4, 3. And then update it with a list maybe. So 12, 13, say. And next, if I print S1, then it should give me the items without any duplication. So you can see all the items in my previous list is now occurring only once. Then the last two techniques are use generators. Generators are very efficient. So to do so, I'm going to create a function sequence. And then I'm going to initialize my num variable, a condition while num is less than 10, yield num. So as you know, in generators, there is no return statement. Instead of return, yield is used. And then I'm going to increment num. Outside of this function, for I in the sequence, I'm going to print I, n, and should be separated by comma. So you can see it prints the number from 0 to 9, and all of them are ending with a comma. So we have successfully implemented generators. Next is examining the runtime of the code that you are running. To do so, you can use time it function. Time it. So I'm going to run this code snippet. So you can see that it took 12.9 nanoseconds to run this per loop basis. So in this way, these are some of the techniques that you can use to write efficient Python code as well as to optimize. I hope you enjoyed this coding exercise. Thanks for watching.